So let's look at one more example of a chi-squared test of independence here. We want to test if political party is related to a person's policy or value stance at the alpha is 1.05 level. So these are two categorical variables. So this is going to be test of independence. Here is our observed contingency table, so observed probabilities. So we've got conservative stance, Republican, Democrat, Independent, liberal stance, Republican, Democrat, Independent. Of course, these terms could mean something different to each party, liberal or conservative inside a party, but this is the data that we've got. Null hypothesis is going to be that party and status are independent. Alternative, party and status are dependent. Our expected counts as before, row total times column total divided by grand total. So we want to go ahead and fill in our expected contingency table and make sure all those counts are at least 5. So for Republican, our Republican conservative, row total was 52, column total was 62, grand total 120. So that's going to be 52 times 62 divided by 120. So 28.866. So 28.87 or 26.87. And then do the same for the rest of these. So pause the video for just a moment and go ahead and fill in those expected counts and see if you match me. So you should have got, for the conservative column, 21.7, 13.43, and for the liberal column, 25.13, 20.3, and 12.57. All the cell counts are greater than equal 5, so we can perform the test. And now we want to compute our test statistics. So that's the sum of observed minus expected squared over expected. So I've got observed column here, expected, observed minus, square it, and then divide. So that first expected count was 26.87. And so 35 minus 26.87 is 8.13. If you square that, you get 66.10 to 2 decimal places. And if you divide this by the expected, you get 2.46 to 2 decimal places. So why don't you try and go ahead and fill in the remaining portion of the table, and then our totals are down on the bottom. And then see if you match what I got. So for your observed minus expected, you should get a total to 0. These values, square that column, so you get the following values, sum to 226.06. Divide the fourth column by the second column, and you should get these values, sum to about 9.68 depending on your rounding. So next, our decision rule, we need degrees of freedom, row minus 1 times column minus 1. So we had, in this case, we had 3 rows, 2 columns. So 3 minus 1 times 2 minus 1. So 2 times 1, which is 2. And alpha is 0.05. Go to the distribution calculator. And so degrees of freedom 2. We want the right tail, 5.99. And we'll reject if chi-squared is greater than 5.99. And our conclusion here, well, since our chi-squared test statistic, which is 9.68, is greater than the critical value of 5.99, we reject H0. So formally, there is sufficient evidence to conclude that party and status or stance are dependent or associated. And then we can also carry out this test on the TI-84. You have to enter your observed values in a matrix, and then you go to stat test chi-squared test and hit calculate. So let's check that out real quick. So we want to go to second matrix, so second of x inverse, and we first want to edit our matrix. So you can name your matrix A, B, C, D, but we'll just do the default. So edit, A is highlighted by default, press enter. If it's not already 3 by 2, just overtype the 3, arrow to the right, and overtype the 2. This matrix will adjust itself automatically to that number of columns. So notice I entered the observed values in here. So I already did that ahead of time. All you have to do is enter observed. You don't have to figure expected. Calculator does that for you. Then you go to stat, tests, and then chi-squared. So I'm going to go up from the bottom here. So chi-squared test is option C. Press enter. Observed are in A, expected are in B. Come down and we will calculate or draw. Either one's fine. And so we see our chi-squared is 9.69, and by hand we got 9.68, so that's confirming our work there. P-value is 0.0078, which is, well, 79, which is less than 0.05, so that's also confirming that we reject the null hypothesis. And then our degrees of freedom are 2, just as we figured. So just a note here, just note that P is 0.0079, which is less than 0.05, which was our alpha. So that is also implying that we reject H0. So if I don't ask you to do the table, you can just use the calculator to do it. But there may be some problems where I have you fill in the table and actually compute that test statistic. And it's certainly okay to check your work with the calculator.